Good morning. Got the air track on and I've got a glider on here and I'm going to have this glider interact with the hoop spring that's at this end over here, the left side. Now that hoop spring is it's the hoop spring that is the not so stiff hoop spring. I'm going to have the glider react with the stiffer one a little bit later, but we're going to look at what does this look like when the glider interacts with that hoop spring. So I'm going to start first my Logger Pro collecting. And it is starting to collect. This is going to interact with that. And we got a graph made where there's a sharp dip in the graph in the red line. So I have two force sensors hooked up here. One's blue and one's red. So the blue one was not interacted with at this time. So the red one was. So when I look at this, you'll notice that the force on here is negative. The reason the force is negative because the glider is moving to the left and the force is acting in the opposite direction of the motion of the glider. So this is when it is starting to compress the spring, the hoop spring over there, and then this is when it's moving away from the hoop spring. So we can see the force is increasing to the max, and then it is decreasing, and then the glider is not touching the hoop spring after this. So we can highlight this area underneath the graph of that hoop spring. And in Logger Pro, if I go up to Analyze and then I go to Integral, that area underneath there is calculating the impulse for me. It comes up saying that the impulse for this is a negative 0.3297 newtons times second. So this area underneath the graph is the impulse. And we know that the impulse is also related to the change in momentum. So it would also equal the change in momentum for this glider. So I want to do this experiment again. I'm going to clear this run. And as I'm going to do this, I'm going to bring this down this direction. We are going to have it interact with two hoop springs. So it's going to interact first with the one on the left, which is the weaker hoop spring, and then it's going to interact with the one on the right, which is the stiffer hoop spring. So try to adjust my camera so we can see all of the track, hopefully. And I do have a post-it note over there saying that is my stiffer one. So I am going to start my collection. Get my glider on here. It interacts with the weaker hoop spring, and now it's going to interact with the stiffer hoop spring. So one is in blue, one is in red. The weaker hoop spring, the not so stiff one, is the one that's in red, and then the stiffer one is the one that's in the blue. So we can see that the one that's in the blue applied a greater force because that spring is stiffer. The one in the red, the force is not as much. We can also see that the time of interaction for the weaker hoop spring is a greater time compared for the time of interaction for the stiffer hoop spring. And that would be typically true. If we can extend the time for an interaction, the force is less. If the time is shortened, the force is also greater. So we can kind of see where that is happening here. So we're just trying to get over the fact that, or understand the fact that the impulse is the area underneath here. And that time of interaction is related to how much the force is. So just like with airbags in cars, we want your interaction time when you collide with them to be a long time to reduce the force on your body so there's less damage done on it. It would be the same thing with like bungee jumping ropes and cords. They want to make sure that when a person falls and they reach the maximum length of the cord, that the cord has a lot of stretch to it so that the time of interaction with the rope is a long time so that you have less force on your body. If you used a rope that had very little stretch on it, you would have a short duration of interaction time, and that would apply a lot of force on your body, which would cause a lot of injuries to bones and organs. So this is kind of the idea of what impulse is. It's that area underneath the graph, and how can we look at the time frame and the force and compare. Longer times give us less force on the object. It's usually what we desire more. So hope this helps clarify what impulse is. And remember, we also said that the impulse, this area, is equal to the change in momentum for an object. So if we knew what the mass of this spider was, and if we knew if I hooked up a photo gate to it, we could get what's the change in velocity times the mass, and it should be relatively close to what is the impulse. They should be pretty close because they are equal to each other.